let's see what happens when we touch one with a lit match. But first, we have to strike it with a rough surface, causing it to undergo a chemical reaction to burn.
Gosh,
Therefore,
dang it.
changing the state of matter, engendering the match to create kinetic energy, emitting heat and light. And the amount of energy being distributed from the kindled match is approximately 614 joules.
Hey! Ah! Ah!
Alex, is the water boiling yet?
You mean to ask if it's at 100 degrees Celsius?
100 degrees Celsius, 312 degrees Fahrenheit, and 373 Kelvin is always the same.
Well, actually, Ricardo, it depends on the altitude or the atmospheric pressure.
Atmospheric pressure!
Shut up, Bond! I don't know how to say it!
Just trying to help, man.
The boiling point can vary. And the higher the altitude is, the boiling point decreases. The lower the altitude is, the boiling point increases. But right here, it's at 100 degrees Celsius.
What? Let's go check on the water.
Let's see if the water has reached a constant temperature of 100 degrees Celsius.
Clearly, water boiling.
Yeah, it is. You know what Mr. Campy says? If it's boiling, it must be at 100 degrees Celsius.
Well, I wonder how the particles are acting in there.
Well, let's take a closer look.
Oh, hey, Alex, do you remember that chemistry term for the amount of particles in a substance?
I think you're referring to moles.
Oh, yeah, moles. So, like, say if I grab this ice cube right here, how many moles are inside of it? Or, like, because it's so cold, it must be at absolute zero, right?
Well, first thing first, it is not at absolute zero, because then that would mean it'll be at 0 Kelvin. And that's when all the atoms start moving completely. And to answer your other question, the answer that you're looking for would be molarity.
So how would you find the number of moles of water per liter anyhow? So like say the mass of this ice cube is 6.5 grams per liter, how would you find the molarity of this?
Ah, that is easy. Just give me a moment. I just gotta go do something really quick.
Oh, okay.
Siri, what is the molarity of 6.5 grams of water?
Checking on that. The answer is about 0.36 molar.
Oh, hey Juan, the answer is 0.36 molar.
Okay. Well, I think I know how to solve it without asking Siri, Alex.
Huh? How'd you now ask Siri?
Well, I heard everything here from the kitchen, and during that time I had an epiphany from chemistry class, and I remembered how to do it. So, here you start with what you're given, which is 6.5 grams over a liter. And all you have to do is get rid of what you started, so you got to get grams below down here, and find the molar mass of H2O, so that the units cancel, and you have 1 mole on top. Then all you need to do is simply divide, and you get 0.36 molar.
I knew that the whole time. I was just making sure you knew.
Sure.
Oh, what's that smell? Oh. My homie Chato came home from his wrestling tournament. Oh, that's noisome. Gotta do something about it. Oh. What is that? Oh, it's Febreze, Chato. You smell. Just, you'll be fine. Just let entropy take its course. And let it naturally diffuse into the air. And since it's hot in here, the temperature is high and entropy also is increased. Oh,
Hey, who sprayed Febreze? I can smell it way over here.
Hey Juan, got an idea. What would happen if you put an ice cube to a hot pot?
Really? You're asking that?
Yeah.
Obviously it's gonna melt.
I know, but in a scientific perspective, what would happen?
Well, Ricardo, to prove to you that it's gonna melt, let's just put it to the test.
Alright. Here you go.
Took you long enough. Anyways, go get the pot.
Wait. No. I don't get burned.
You're not gonna get burned. It has a rubber handle, which means it's an insulator, which protects your hand from getting burned. You will get burned though if you grab the metal, which is a conductor of heat.
Alright. Here you go, Juan. Juan, will you explain what's happening?
Well, as you can see, the ice is undergoing an endothermic process, meaning it is absorbing the heat around it. While on the other hand, the hot pot is undergoing an exothermic process by releasing the energy in the form of heat.
Don't forget that the ice cube just decreased its volume and the temperature and pressure have increased due to the ideal gas law. That's science. This is why birds fall asleep on the job.
Hey! What the heck are you doing, dude?
It was this moment where Juan realized he fucked up.
Get up!